All right, hi everybody. This is Mrs. Harding. I know this is kind of a weird way to learn your lesson today, but the earliest I'm going to be back is on Friday. So we're just going to kind of have to bear through it and use this as a resource as well as your books and each other. Okay. So yesterday you guys were supposed to learn how to solve systems by graphing. Remember that a system of equations is two or more variables within the same equation, as well as a solution to a system is the point of intersection. So yesterday, what you should have done is graphed each line, see where they intersected, and that would have been the solution to the system. Okay? Please also remember that when you write a solution to a system, it must be written as an ordered pair. Otherwise, I will take points off for it. Okay? So yesterday you learned about graphing. Today you're going to learn how to solve systems using substitution. And then on Thursday, you're going to learn how to solve systems using elimination. Okay, solving systems by substitution is exactly what it says. You're going to end up substituting a number in for a variable or an expression in for a variable in order to be able to solve for it. So let's just take a real basic one at first. Y equals 4 and 2x plus y equals 1. So yesterday, you guys graphed these and see where the point intersected. Make sure you solve the slope-intercept form first. But today, the only thing that we're looking for is a variable to be isolated. Okay. And with substitution, it doesn't matter which variable, it just needs to be one of them. So if we look at our first system here, notice that y is isolated. Okay? So we're going to take y and substitute it in for the other equation with what it said equal to. So since y equals 4 here, I'm going to substitute into the second equation and make that also 4. So I have 2x plus 4 equals 1. Okay. Then we're going to get 2x to equal negative 3 and x to equal negative 3 halves. Is it okay for an answer to be a fraction? Yes, it is. Okay, but in these, please remember to keep them as fractions and not as decimals. Now, like I mentioned before, you must write your answer as an ordered pair. Okay, an ordered pair is surrounded by parentheses. So our final answer is negative 3 halves, comma, 4. Okay. Of course, you can check your work by taking both the numbers, plugging them back in, and making sure that each equation worked in the originals. Okay, this one just equals 4, so we're good on that one. Check the other equation. 2 times negative 3 halves plus 4 does equal 1. So negative 3 halves 4 is my answer. Okay. Nice thing about systems, you guys, is that you can always check your work and you always can find out if you're doing it incorrectly or not. And of course, you should be taking the time in order to figure that out. All right, let's take a look at another example. We have y equals 2x minus 5 and 2x plus y equals 1. Remember that in the previous example I just stated that you need to have a variable isolated. Well, if we look at both of our equations, hopefully you notice that the top one doesn't need to have a variable isolated. Okay. So I'm going to circle the y's because that's what I'm substituting, and I'm going from the top equation to the bottom equation. In the top equation, y equals 2x minus 5, so that's what I'm going to substitute into the bottom equation. So 2x plus 2x minus 5 equals 1. Okay. Now remember that the whole point of substitution, hopefully you read your book last night, is to get down to one variable. Okay, you can't solve a system with two variables because you don't know what either variable is. So by substituting, we get down to one variable, and now this is a typical equation that you've seen before. So we have 4x minus 5 equals 1. Four x equals 6, x equals 3 halves. Okay. Once again, it's okay if we get fractions. Okay. Now remember that a solution to a system is an ordered pair, and right now we only have half the ordered pair. So we need to take the 3 halves, plug it back into one of the original equations, It doesn't matter which one we use, preferably the one that already has y isolated. So y equals 2, 3 times 2 minus 5, and we get y to equal negative 2. Okay. Now hopefully you guys will know the answer to the next question, and I would ask you, why are we not done? Okay, and hopefully you answered with 2 reasons. 1, we need to write it as an ordered pair. And 2, we need to check our work. And since we just used this top equation up here to figure out the missing variable, let's use the bottom one to check. So 2 times 3 halves plus negative 2 has to equal 1. 3 minus 2 does equal 1. I did it correctly. If you're not sure which equation to check, just check both to be on the safe side. All right, take a look at another example. Now remember that the whole point of substitution is to eliminate a variable to get down to one variable, and to start we need to have a variable isolated. Well, if you look at number 3, we do have a variable isolated. It doesn't matter if it's x or y. Okay, so we're going to notice that, hey, the x is isolated. So this time we're going to work from the bottom equation up top. And we're going to substitute in what x equals into the top equation. So 5 times y minus 1 minus 2y equals 4. Okay. Notice that I replaced this x up here with what it equaled down here. You're trying to get down to one variable. So 5y minus 5 minus 2y equals 4. We get 3y to equal 9, and y equals 3. And hopefully you notice, or it rings a bell, that you're not done. We still need to find x, the other half of the ordered pair. So let's plug it back into one of the original equations. It doesn't matter which one we choose. This one already has x isolated, so let's go ahead and use that one. So we get 2, 3. Okay. And let's check our work to make sure. Since we just used the bottom equation to find the missing variable, I'm going to go ahead and use the top equation and check my work. So 5 times 2 minus 2 times 3 equals 4. 10 minus 6 equals 4. Make sure when you guys do the arithmetic that it actually makes sense. Don't do this, because that obviously is not true. Okay, so when you check, make sure that it works, and 2, 3 is your answer. Okay. All right, this concludes part 1 of the lesson. What I want you guys to do now is take a moment, go over the examples with your DFFs, see if you guys have any questions. Only take about 2 or 3 minutes on this, and then we will start the second part for the next 3 examples.